So we've all had to validate some data in our career as a programmer, right? That's when you have to check if the user entered the password, and if that password has 6 characters long and has enough types of characters that you can actually hash it and send it to the server to check if it's all right. Here we're going to talk about 4 tips that can improve the way you're validating data. So let's take a look at this example here. We're going to start now with the examples, and then we're going to see what's the actual tip, all right? Okay, so what does this code do? Well, we have a store that sells candies, and it's trying to refill all the candies basically, and it's checking if there are any candies to refill, if the store is open and you can actually refill, and if all the candies are low, then you do refill and you send a notification or whatnot. Okay, and whenever one of these fails, we can notice that we're actually printing an error to the console. So there are multiple problems with this code. The first one being is it's hard to modify the conditions. What does that mean? Well, okay, sure, we can actually modify and say instead of candies, candy array. That's fine. But if we want to change their order, we would have to basically move this if down low and change the else between them. And it's kind of difficult to actually pair them up, especially if you want to also add or remove a validation case. Okay. Another problem is it's hard to see which condition is paired with which error, right? I mean, sure, we have indentation here, that's nice, but it's still kind of difficult. Like, okay, well, we have here else no stores to put into the candy. Oh, well, where's this? Oh, it's here, like 10 lines above, right? It's not that great. Another problem is it's hard to see what the code normally does. Like, you have in front of you everything that it checks, and the end of the code block is filled with error messages, and in between is what the code normally does, and that's kind of difficult to see, like, at first glance, right? We want our code to be readable, but you should be able to read it really fast. Okay, so what can we do here? Here's a really simple strategy to improve this code. What you have to do is to simply take each condition, first invert it. So in this case, strictly higher than 0 would become less or equal than 0. Well, if it's a length, then it cannot be less than 0, so we can leave it as equal 0, okay? Then copy the error message or the else block on here inside the if, return or whatever else comes after this if else block, and then end bracket, and that's it. That's a really nice way we can improve readability, right? We have the condition here, and if this is true, we know that we're actually printing out an error, so it's an error, and we're also getting out of the function. Return null, return whatever you can as an error message. Okay. And then we can remove this else block. Same thing goes for the next one. You can just say if not store is open, then simply copy this error message and return. And indent it properly. Same with this one. If not all are low, then we copy this error message, return, and that's it. And then we can remove basically every single else message, and here we go. And now it's really readable, right? You basically have every single exception or error that can occur before actually executing the function's code before it, and treated with its condition and its error message, so you know which is which, right? Which pairs with which. Also, it's easier to modify. You can add a condition wherever you want. For example, you can add one here. It says if candies.sum. You can do that. It's pretty simple. You don't have to nest everything and then indent everything and then be like, whoa, we have like 5 indentation level in one function. No, you don't have to do that. And also removing one is really simple, or changing orders, same thing. And the actual code for the function after all the validation is very very readable as well, because you can see it at the end here, right? You don't have to look for it inside an indentation code. So that's the first tip. It is invert your if statements. Okay, do that. Most of the time it's gonna work. There are some cases that it's not, but this usually works like 90 to 95% of the time. Okay, next tip. Okay, let's look at the example here. First we have a car repair object, right? It's instantiated like this, and we're checking if it's null. So something happened in this function that I don't know what, but it returned null for some reason, okay? And we are checking if it's not null. The problem with this is we don't know if our code actually did something right or not, because there might be some more validation here where we might not know in advance. So it would be nice to know exactly where the problems are. Okay, so here we would do something like if car repair is not null, sure, but then you would actually add an else here and say, okay, well, if that's a problem, then do system.out.error, yeah, and something like the car repair is unavailable, just some error message, okay, and that's about it. And now we can actually apply the first rule, where we just invert the if and return. So we can just do if this is null, then you just print out an error and return, come on, and like that. And now we have a really nice way we validate, right? So we are just instantiating the car repair, then we're just validating it. And these two really, usually you can notice them together. So your mind kind of goes, oh, okay, so this is where it does car repair stuff. And then that's where the actual code starts. You can, of course, you can just add a new line here, for example, to split them up, but it's very readable like that. And we also don't have an indentation level here, so this is really nice. Okay, so what's the tip? The tip is don't let errors fail silently. Okay, that's really important. Sure, if you use exceptions, this will automatically be handled for you, so it wouldn't ever fail silently unless you explicitly code it so it does that. But in some cases, I know that there's a big part of the community out there that doesn't use exceptions, and this kind of works for them. Okay, and it's really nice that it links back to the first rule. Okay, let's go over the next tip. Now the next tip is very simple. All you have to do is return a proper error or throw an exception. Okay, here all we're doing is creating a route from a certain string, and we are just validating it, right? We're checking if it's actually valid, and if it's not valid, that's nice. It's applying the first and the second rule, but what it's doing is returning 0. In this case, 0 is actually a valid return value, right? So let's look at the signature of this function. All it does is get coordinates count. So if you would pass in a valid route string that doesn't have any coordinate, for example, you will also be getting 0. And that's where the confusion arises. Do you check if it's 0, or what do you do in this case? Like, think about the person that tries to call your code. What does it do if it encounters an exception where, well, the route is invalid, but it also could be valid if it had no coordinates? So the solution here is for you, the creator of the function or method in this case, is to return an invalid value. For example, what we can do here is simply return -1. It's not a best practice, but it gets the job done because we're getting the coordinates count here, right? And it cannot be -1, that doesn't make it. Like -1 coordinates, that doesn't mean anything, right? And the programmer can then check, oh, is this less than 0, then we have a problem, okay? Or just throw an exception. I don't know, if you use exceptions, I don't use them too much, but if you do use exceptions, sure, go ahead and throw an exception, but please don't return 0 or something that is actually valid. All right, let's jump to the fourth and the last one for today. This one is fairly obvious, but we've encountered that quite a lot of times in the industry, and we want to bring awareness. It happens when you as a programmer, you have to make a lot of assumptions, right? You have to make sure, you have to assume that your framework works, right? Assume that your browser does everything for you in JavaScript. Assume that the Java SDK works as expected, as in the documentation, right? Same goes for your code, all right? So let's take a look at the example here. Here we have a function that gets all ideas from the server, all right? So we have a get all ideas URL, and it returns a promise. Fair enough. Now, what's the issue with this code? Well, it doesn't make a simple assumption. Here we have a constant object, and let's say that our constant object was created by us somewhere else, right? And we have a property here. This property is instantiated by us again, but then why are we taking it as an URL and also checking it if it exists? Because if at any time our code enters this block, that means that we've made a mistake, right? We as a programmer made a mistake that we should actually correct ourselves. Not the user, not the one that's using your function, but you yourself, the programmer. So in this case, you would really want your code to fail. Because if at any time this code fails, you notice that, oh, well, of course it failed. I forgot to properly define this property, or I used it improperly where RL is lowercase or something else. And then that's obvious, then we don't need to check this URL. We don't need even, or maybe we do want to use a variable here. Sure, that's fine, but you don't really have to check. Because if you do check, then your code doesn't fail. That's why validation is there, right? It's so that your code does not break down because of one user input that was wrongly sent to the server or to the client, whatever that is, right? But this is not a user error, this is a developer error. So you don't have to check that. So the last tip is don't validate developer errors. Really don't. We want our code to fail when we are at fault. Okay, so just kind of remove this if statement, and sure, you can leave it as a variable. I prefer not to, but whatever goes for you. But just don't check if your code actually has errors, and just return like everything's okay. So thanks for watching. For more content, go ahead and hit the subscribe button, and see you guys next time.